to construct a parabola given the axial length and the span. In this case, we're going to consider drawing the span and the axial length. Okay, so we want to draw a rectangle to the centermost part. So I'll set off a base first. From the edge of the paper, you can set off going up. You can set off 50 or 60. Let me use 60. From the edge of the paper, you measure 60 millimeters. No, less than that. 50. Okay, and at 50, then you draw a line. This would be our baseline. The moment is just a construction line that we need. Just a construction line. On this construction line, we want to draw the required distance. In this case, we're going to set the base to be 100, which is 10. I want to ensure that it is merely to the center, so that would be 10 centimeters. 1, 10, 100, right? Which is 100. Then I'll use my set square to construct that rectangle. At the moment, construction lines. Okay, so we have already 1, 2, 3. We need the top. Okay, and this top is the height is, or the span, the axial length is 120. So that's 10, 20, 30, 40. That's 100, 120. Up to there. So once I've established that height, I can draw that horizontal line. Okay. So this is the rectangle. And I want half of this rectangle in terms of the base. Remember, the base was 100, so I need to establish a point 50 millimeters. 50 millimeters, and at 50 I will draw a center line. Okay, a center line. So I have 50, 50, and that makes up 100, and then the span, the actual length is 120. In this case, 120 is for the height, or the actual length. I need to divide this distance into 4 and this into 4. Whatever distance whatever number of equal divisions I decide for here, I should have the same number here, and also I should have the same number here. Okay, in this case, I will divide. First, let me divide the height. In this case, I'll set my ruler, my set square in this case. Extend a line, and then divide here. I'll set every 2 millimeters, every 2 centimeters. That'll be 1. It's 1, 2, 3, and 4. So put 1, 2, 3, 4. Okay. Then join to obtain those 4 divisions. So that's 1, 2, 3, 4. and the same thing I need to do here, divide to 3. But because it's half, then I divide this into 8. Any angle? Here I'll decide to say every 10 millimeters or every 1 centimeter. So I'll be 1, 2, 3, 4, 5, 6, 7, 8. And join the 8 to the last point here. Okay. I want to transfer these points to my left. So point 1 here. Just place a line over the other onto the left hand side. Point 2. There's no need for you to draw a line. Just a small line onto this point, and then 4 would be that point 4 there. Okay. And the same thing happens for the top, but the exception with the top is that I need now to draw vertical lines at each of these points. So I'll draw, we're using construction lines. 1, exactly onto there. 2, let's reach that point, and then 3. Okay, 4 is the center. Then 1 again. 2, then 3. Okay, if necessary, let's give a name to these points. Let me set the labeling below and here onto the left hand side, because it has the divisions already there, and then it's too much alignment and too much lines, too much there is a construction, so it will not interfere with the lines, and so you don't get confused. Then we label onto the bottom and then onto the left hand side. Okay, so these points will be labeled accordingly. This point is 0. This is, I want them to be aligned, so that's 1. Okay, 2 and 3, and last but not least, this point is 4. Okay, so this point would be 1, 2, 3, and then we already have 4. So this is 1, 2, 3, and this would be 4. In a similar manner, this is 1, 2, 3, and then this one is 4. Okay, we are going to use this point of reference, the center line, and we're going to join the center line here to the top to point 1 on my left and point 1 on my right. Center, point 2 on my left, center, point 2 on my right, point 3, point 4, point 4, sorry, to the bottom. Okay, So we're going to go one by one. On my left hand side, I'll join point 1 to the center to the top. Construction line. Point 2 to the center. Point 3 to the center to the top. Point 4 to the center. Okay, and in a similar manner, I'll do this one. Center to 4. Center to 3. Center to point 2. Center to point 1. Oops, some mistake here. One. And that's why it's important you use construction lines. Okay, and then 0 to 0. These are the points of reference. This is 0. This we'll start on the left hand side. This is 0. We want to see where this point 1 intersects this point 1. So we're going to follow 1 here. It goes to the center. Okay, and this is line 1 to where 1 intersects the line inclined. So this is my first point. Then I'll say point 2, line 2. Where do these two intersect? And that is right there. That's the second point. Line 3 on horizontal, line 4 on vertical. Where do these two meet? There. And last but not least, 4 remains 4. In a similar manner, line 1, say 2 with line 2, they intersect here. Line 3 with 3, they intersect right here. And then 4 with 4, which is here. Okay, so you have 1, so you have 4, 3, 2, 1, 0, 4, 3, 2, 1, and 0. Last thing to do is to join. Okay, so I'll join this. And also let's see what it goes there. There. Okay, subtopic, five millimeters. This would be to construct a parabola. given axial length and span. Okay, so that would be the construction of the required parabola. Okay guys, thank you for following.